Hello, am I here now? Yes, yes I am. Okay, welcome, ladies and gentlemen and cretins, creatures, all creatures of the world. I am gonna do some magic coding. This is where we were the last time. Um, so let's pick it up. This is nowhere near what we want actually. This is a bit too skewed because we've got the mandelbrot basic shape, and then we have these refractions, or I don't know what it's called. It's like, okay, let me go here. I think there's a name for it. I mean, Buddhabrot is the name for the whole thing, but yeah, it how to map trajectories to pixels is a matter of projection. Yeah, so we have some projections of it here. Oh, just a second. Um, I need to tweet this out. I don't think anyone's coming through Twitter, but still better to have something. Okay, going live. What am I doing? Buddhabrot, mandelbrot, spicy cousin. Uh, drawing Buddhabrot on or on canvas. Um, I don't know why I'm doing this. Let's just get it over with. Add the monad. Yep. Let's go. All right. So back to where we were. So the way we had it, um, actually we don't need this. Yeah. So this purple region is the specified boundaries of Mandelbrot set, but it's not the exact boundaries, but it's an approximation of it. Actually, we can move this thing here because if it doesn't escape, we deal with it for the Buddhabrot set, but if it does, it's Mandelbrot set. So if it doesn't escape, it's Mandelbrot set. So yeah, we get the same result without the arbitrary 20 or anything, 15. Yes, so this is our state currently. Last time we didn't create a commit, so let me just do that real quick. Buddha, Buddha, Buddha brought magic. I don't want to. Oh fuck! I screwed it up. Let's try it again. Buddha brought. There we go. We have our committed. All right. So what did we fuck up? Is something that I'm still not clear on. We've got our. So we scaled it up. We added the offset. All of it seems perfect, but I don't know what's wrong. Okay. Row. Wait. Yeah, actually that's correct. My god, this is screwing with my brain cells. Got it here. We get the index, we get the row and column from that. But when we're here, we we oh no, something seems wrong. This is correct. So I'm a little confused about the row because if we have the row, we scale it up, we get the offset. So the thing I'm confused about is, do we need +1 here, or do we need seal here? You know, because would the row be the y value that we get, or the okay, let's run it and see. Okay, that got screwed up, so I'm guessing this is the right one. That got darker. It doesn't matter. So that's not it. I mean, while we're at it, might as well just see what this does. Nothing. Back to this guy. We've got 4 row times canvas dot width, row times canvas dot width. No, row -1 times. Oh, this actually makes sense. Okay, that what difference did that make? Okay, there's a line there that disappeared. I don't know if that's a good thing or a bad thing. I'm pretty confident this is how it should be, because we do need the row to be so row -1 times the width are the cells above it, and then we add the column to get the index. So I think this is the right one. I'm still not sure because there's a line that appeared here, bright line, which I'm a little conflicted whether or not that's a good thing. But yeah, that's where we are right now. Okay. Oof. What else? Okay, let's just read. Let's do some reading. I found this, but I don't see anything technical on it. It's like it's just showing up. I think this is the person who invented this technique, like discovered it. And yeah, it's basically Mandelbrot set, but drawing it slightly different. The other shows the overall entire Buddhabrot set. To produce the image only requires some simple modification to yes. Instead of selecting initial points on the real complex plane for each pixel, initial points are selected randomly from the image region or larger as needed. Okay, that's something we're not doing yet. Let's see if we learn something. So initial points are selected randomly from the image region or larger as needed. Then each initial point is iterated using the Mandelbrot function in order to first test whether it escapes from the yes, we did that. Only those that do not escape are then reiterated in the second pass. Okay. Sorry about that. I've got a cough. Just 1 second. I need to drink some water. Not sure what happened to my throat today. It was fine like an hour ago. Yes. Where were we? Which part of this? Only those that do escape are then reiterated in a second pass. Yes. The ones that don't escape are believed to be within the Mandelbrot set are ignored. During reiteration, I increment a counter for each pixel that it lands on, yes, eventually exiting. Every so often, the current array of hit counts is output as a grayscale image. Eventually, successive images barely differ from each other, ultimately converging on one Okay, so they are randomly selecting a set of points and layering them on top of each other. I mean, what we're doing is we're doing it for every point on the canvas. I don't know if so. Do pixels, so if you're randomly selecting it, wouldn't there be duplicates? And in those cases, do we just ignore the duplicates or do we add on to them? Some things are a little confusing about this. The sampling bit. Successive images barely differ from each other, ultimately converging on top of each other. I'm the most unreligious person you could ever meet, but it's hard not to. God damn it. that went in a cheesy direction. Couldn't you just explain it to me? Yeah, I'm not hiding in something but a single image in plain sight, suggesting that the Hindus were the ones who got it right. What the fuck? Just couldn't you have taken like two more sentences to explain what is happening? I still have no clue. Um, okay, let's think about this again. To produce the image only requires and reiterate it in second pass. I mean, more or less that's what we're doing right now. So yeah, here's the thing. We run the mandelbrot thing and we get a list of points, a list of points that we visited while traversing through the mandelbrot set. And if it escapes, we yeah, we ignore it in our second pass here. If it doesn't escape, we ignore it. If it does escape, we go through the points that we visited and we increment the opacity channel, alpha channel, and that's what is happening right now. Oh, by the way, and I also changed one thing. I instead of visiting the file server, I added live server here. Doesn't matter, just it's a quality of life improvement. So it does live reloads and stuff. It's kind of fun. So I mean, I'm bringing this back because I don't understand the white line that we're getting. Doesn't matter. Okay, this one is a bit tricky because let's think about this again. Let's put it to the side and not look at it. let's do this all over again and see if what we get at. So row is so to get the row, what we need to do is we get the y. We basically reverse whatever we did above, right? We get the y first. We take the y, we scale it up, we offset it, and yeah, that's it. I mean, okay. I guess we did the same thing that we're explaining. I didn't see a reason why we have to do this again. This bit is, yeah, a row and column has to be greater than 0 because that's what we're dealing with. And also it has to be within the canvas boundaries. That's what we're checking here. And if it is, we find out what the index position might be. I'm still conflicted about the row part because when I call it row, is it really row or is it row minus 1? Because when I get the y and I floor it, I feel like I'm getting row minus 1 instead of row, because in that case I don't need to do an additional minus 1 here. But if that's not the case, I do need to do that. So I'm not sure what to do there, but let's just try a few combinations, -1 gave us, yeah, that bright line. -2, -3. Oh, it just offsets it. Okay. I mean, after that, it just makes sense. +2. Okay. Nah, that's not really helpful. What am I doing wrong? So we've got the index. I feel like this is where we're fucked up, but a little unsure about this. Let's go back to our reference here. I feel like we've followed this bit, but minus the random sampling. Instead, we are just doing it for all the pixels in the canvas, which I feel like should be fine for the most part. But yeah, it does mention here that these different random samples that we get layer on top of each other. So not sure if that's an important bit that we're ignoring here. Anyways, let's look at something else. We had this important sampling, which I don't understand. It goes above my head. Not smart enough to do this. Parse and let's take a look at this. Use symmetry. I don't. Okay, Buddhabrot. This is what I want. Let's restart. Make symmetric. Now I don't want to do additional work. Let's just do the work that we have to do. Global composite operation. Oh, didn't know that was a thing. Doesn't matter. We are going to focus on what we're doing here, which is what were we doing here? Canvas context, image file and image. What? There's an image input here. Okay, no, we're not going to go there. Let's see where it draws the thing. Okay. Okay, it's not offsetting anything. It's just... Actually, you know what? Let's get rid of the offset. I feel like that just adds an additional bit of... So, I was thinking if we will be able to move around this after it's drawn. So, but that will also be much trickier than I'm imagining right now. So, let's not have it at all. I mean, this part we'll need because we need to shift it to the center, but other than that, okay, yeah, let it be. I don't want to just, yeah, I don't see any difference there. So, what do we do here? Offset. Index. Now that doesn't matter. Back to this guy. Rotate, scale, center X plus that guy. This is just the coloring bit. Doesn't matter. Iterations. Yep. This is the Mandelbrot calculation. Mandelbrot fractal equation. Yes. Rendering the pixel. Oh, it draws a rectangle of 1 pixels. Okay. I mean, what we're doing is a bit different. So for us, the image just shows up as the whole thing after a bit. But here, they're drawing individual pixels on the screen, which we might switch to if that seems better. But Actually, we'll have to switch to it if we're going with the worker approach to speed things up. But right now, what we have is this guy, and I don't know why it is so skewed. So let's go through this again. Um, it's drawing the points. So the points are the ones collected for the Mandelbrot set, like the paths that it traces, and it rates over the points here. For each of those points, we're just drawing it, and this is the conversion bit. Okay. Um, you know what? Let's do it this way. Let's switch over from. So what we're doing here is we're just getting the pixels on the screen and we're transforming it. Instead of that, what if we just plot the points as they are, the way it's being done here? Or maybe we do get the image data because we'll have a list of pixels to iterate over. The only part that changes now is this guy. We don't need that anymore. We also don't need this one. Oh, okay. This does pose an issue. How do we layer the opacity on top of each other? Let's actually, yeah. Okay. Let's comment this out. Let's do it here, right? So we have ctx dot direct. We've got x and y, which should be our x and y coordinates, which I've forgotten where we stored. Yeah, c dot x, I guess. No, row and column. Yes, row and column is where we need to do that. Okay, so x would be column, y would be row, width is 1, height is 1. All right, and we need to set the color as well. Fill style equals red. There it is, Mandelbrot. All right, now that we have this, we don't, I just commented it out, but now that we have that, we can do the same thing here. But okay, let's see. Can we? There is something here about it. It's something about composite global composition operation to increment pixel colors. Yeah, let's try that. Can we just set it outside? Let's see. Let's try that out. We fill it with RGBA 255, 0, 0, 10. I hope that's how it works. Like it layers on top of each other, but can't be sure. Let's see. Okay. Did that almost work? I feel like it did. I mean, it's a little too red to say, but let's see. Let's obviously let's reduce the amount of red that we're using. Come on. All right. I feel like we're on the right path here. I just need to figure out how do we layer the opacity on top of each other, because we don't want. What if I do reduce the opacity, or does it? No. So we don't want it to just fill that pixel. We want it to layer over the previous pixel. I'm not sure how to do that. How do we achieve something like this? Let's comment this out. I feel like that was the issue. The index that we were calculating here, I feel like there was something wrong with it. I can't figure it out what, but yeah, this seems to be the right way to do it. And it's symmetric, which is like a plus. All right. Fill style. How do we deal with this? Uh, we've got a fill rect. Let's see. Let's see. This guy. I don't understand how this works, but let's just blank Google. Um, Canvas. How to um, write over? No. Overlay pixels? No, no, that's not it. No, that's not even close to what I want. Uh, over overlay pixel data. Maybe this have a look at this. Is this kind of okay? Broken link. That's always a good sign, right? Canvas overlay, canvas on top of canvas shape. Oh, this is doing the same thing that we were doing earlier. I'm not confident enough in the index calculation to do that again. Create image bitmap. No, 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 no. Don't do that. No, that's not it either. Let's think. How do we write over a pixel? Can we get? I mean, I can think of a terrible way to do this, which is to use get image data to get the pixel, but no, I'm not going to do that. I'll hate myself forever if I do that. I mean, I already hate myself, so might as well do it. Let's do our no data. Data would be RGBA. Actually, we only need might as well. Okay, actually no, we don't need RGB. We just need okay. This is ctx.get image data, and the x and y is col comma row, and width and height is 1 pixels. Okay, we are getting 1 pixel. All right, so the fill style would change to string interpolation. Here we have that, and alpha plus 10. So by default, oh wait, we'll have to set the default alpha channel to 0 as well. Okay, okay, actually we can do that by just setting the fill style, I guess, or we can just sell fill rect here. 0 0 canvas dot width, canvas dot height, fill it up, and we set the fill style to something, yeah, 0 transparent. I don't know if that's the default behavior, but I just want to make sure. We get the alpha here, we fill the rectangle. Let's save this. Okay, it's taking a bit to reload. Not a good sign. Let's see what happens. Oh, nothing happened. We did the exact same thing twice. That's nice. What did we do wrong? I still feel like we're on the right track. Let's look at the Wikipedia Buddhabrot, one of these. Okay, look at this. Look at this. Doesn't that look the same, like the same thing? Almost the same thing. We're going to get there. Don't worry. It's going to take some time, but we're going to get there. We get the alpha. We increment it by 10. Let's log it. Oh, this is a terrible idea. My browser is going to crash. Let's let's reduce the size of the canvas to like 50. Okay, that's nothing. Literally nothing. Maybe it's because of the offset actually. Let's remove the offset. Okay, that's better. We've got, oh, we only have 0 or 255. That's bad. Oh, wait, RGBA. Does this syntax take in 0 to 255 or 0 to 1? Oh, let's, should we should we just test this out? Let's see. Let's set the background here. Can we change it to RGBA? Oh yes, the alpha is 1. Yeah, the alpha is supposed to be 1. Okay, so let's increment it by 0.1. Let's see. Okay, something changed. Something happened. Let's go back to our 600x600. Okay, it's reloading. Give my PC some time. It's not the best, but it's trying to do its best. It's overheating a little bit, but it's going to get it done. It's a trooper. My god, struggling. Yeah, it's not. Oh, CPU is going off the rails on this. Yeah, that's fine. It's gonna pull it through. Let's do this. Oh, just 1 second. Okay, yeah, nothing happened yet. I feel like this is frozen. Oh, right, console. Holy fuck. Holy fuck. That explains it. Let's open a new tab. Let's do this in a new tab. I don't think this one is gonna pull through. Oh no. Oh no. Permanent damage. Localhost 8080. Come on. You can do it. I believe in you. Oh my god. We are so close. I can feel it. I can taste the mandelbrot, the mandel fruits. Oh, it's taking. This is only 20 iterations, by the way. So, yeah, this is not a good sign. I mean, this is the culprit, basically. This is the reason why it's taking so long. So, maybe we'll have a better time. Oh, what if we cache it? Like instead of, I mean, when I say cache, I mean, what if we save the pixel information in like a map of sorts? And let's just create this. Try it out. Image data map or alpha channel map, new map. Okay, let's set the set a plus. Okay, the pixel we'll have to encode it into a string like this. We do row hyphen call, but I mean doesn't really matter. Let's do a here, a plus 0.1. And okay, no, we just, yeah, oh wait, no. We'll have to create a new function for this. Let's do get alpha x comma y, and we get that information from here, and we also have another function set alpha. So get alpha would first check get row comma, or let's just do return or what am I doing? Get row comma call. Actually, x comma y is more relevant here, x comma y, and we just get it. We get the alpha channel here, and we do the same for set or something similar, and we just set the value. And over here we can just do, or wait, actually we also need to default the value to 0, or we also have 255 to 1 conversion as well. Nah, that's fine. We'll deal with it as 0.1 for now. It's a little confusing. Let's do alpha equals get alpha. We give it call comma row, and we do 0.1 here, and we just set this, and when we're done we just set it back. Set alpha row check row comma call comma alpha. Oh, I forgot A. This guy needs an A. Alright, I feel like this is we don't need that anymore. This should work, right? Okay, close enough, but I expected it to work it the way it did before, but it didn't. So oh, this is, let's try 10. No, too bright. Abort. Back to this. There is a line in the middle and this line here, which I don't understand. But other than that, seems like it's doing something, right? Or is it just me? Should I? There's a few artifacts here and there which we need to clear up, but God, let's remove the old ways, our ancestors' ways of doing things. Let's remove that. What does this do? Okay, that just ruins the whole image. Let's remove that. That's gone. We're painting over, and also, oh, actually, now that I think about it, we don't need this to be global. We only need this to be available. No, we actually need it to be global. No, discarding that thought. Let's come back here. We don't need to do this. Global composition. I don't know if that's doing anything here. Oh, that was doing something. Okay, I feel like, let's comment that out. I don't know its relevance. Let's Google this as well. MDN, what is it? Property of canvas. It's a type of compositing. Okay, let's see what these are. Source over. Okay, source over is the default, I'm guessing. Yeah. Source in. Oh, nice. Source out. Difference. Destination over. Destination. Don't care. Lighter makes it, okay, brighter. XOR. Multiply. Okay. Multiply, I feel like, is relevant. Or overlay, combination of multiply and screen. Dark part become darker, light part become lighter. Let's try all of these. Let's see what happens. Let's see, multiply. Okay, that became darker. Screen. Lighten is what we had before. Or is it spelled something else? Lighter, sorry, not lighten. We've also got overlay and oh, there is a lighten. Lighter, color dodge. God, there's too many things to worry about. I feel like we don't need to deal with all of this. Let's just do source over. I feel like, is that the default? Let's confirm that. If that's the default, we don't need to even worry about this. Source over is the default. Yay. Got that. Okay, nothing changed, which is a good thing. So, yeah, we are now using our map for storing the alpha values, which is fine for the most part. I'm not happy with the solution, but it works. It works. All right. There are a lot of like lines and artifacts here and there, which I don't understand. Let's look into that. And two. Way too bright, actually. Let's make this 200. Okay, this is more crisp, slightly more crisp, but so I can see the projections of the mandelbrot set here, which matches this guy. I feel like we're doing some good progress here. Yeah, I still don't understand what the lines are though. Let's look into that now. Let's commit this. We are 10x developers and we always commit our code. What is the commit message? Did good. Keep going. You know, sometimes you have to leave some motivational messages for yourself. You know, you have to be nice to yourself. Yeah, boundary. I feel like that was an arbitrary value. I feel like 2 is fine, so let's remove that. Yeah, what do we do here? Hello, how are you doing? My dog just started bothering me for no reason. What do you want? Just eat. Okay, back to the mandelbrot, the Buddhabrot actually. So we've got the technique right, which I think I am proud of. Crisp pixel art. Can't get any more crisp than this, buddy. What do we do here? I feel like there is still some unnecessary compositing happening because my pixel should have just overwritten the old one. I don't know if that's happening. How do we do that? Can we do something stupid here? Something like this. Just 0, 0. And alpha is 1. What happens? Okay, we just ruined the progress we made. Abort! Abort! Okay, shit, that was a terrible idea. Debugging a canvas. How do you do that? Because obviously it's 600 pixels of expensive computation, so I can't really console log the whole thing, so that's out of the picture. But Let's lower the res on this guy. Let's do 10 to 10x10. Let's remove the offset here. Is there any other magic number that I have to worry about? No, no, everything seems fine and dandy. Yay, let's look at that. Look at that cute little picture. Oh, how are you? Let's zoom in. So, yes, that's the quality on my stream over here. um, okay. Let's see if I don't know what we are going to get here. What's the point of this, to be honest? Why am I doing this? Let's console log this. Console log row comma column. Actually, it should be column comma row. Console. Is this helpful in any way? No, it's not. Um, what would be helpful? Actually, let's see. What would have gone wrong here? What could have gone wrong is where we are plotting it, right? So when we get the number of pixels, right? When we get the number of points from the mandelbrot traversing, we convert it to the pixels on the canvas, the row and column in the canvas. Actually, it's more relevant now to do X and Y. We did row and column before because, oh, let's rename this. We did row and column before because we were using get image data to plot the whole image. Like we just get all the pixels in the image and we iterate over it and we put it back. And for that approach, it made sense. But here, X and Y is better. This, I feel like, is the only thing that could go wrong, but it seems to be correct. What do we do? Pixel. I'm gonna go take a hydration break to just cool off and come back with a. I'll just replace the brain that I have with a better brain and see if that helps. Goodbye. Let's use the nicer screen for this. What was it? Any text. I am back, ladies and gentlemen, and JavaScript developers. Yes, what were we doing? Good question. I have no clue. Okay, let's go back to, I don't know if that's helping at all. Let's go back to the full image. Let's get rid of this. What would explain darker shades over there? Do we need more iterations? Let's try that. Maybe that'll make something better. Let's do 100. I'm feeling adventurous today. What does this do? Oh, okay, it just made it brighter. I mean, yeah, that makes sense actually. Okay. Can we? Okay, this one needs to be max 1. I mean, that wouldn't actually. Oh, holy fuck. Math.min. Oh, yes, yes. That was stupid. But, okay, what if we reduce the original value and then we incremented it by bigger value? What happens then? A brighter pixel. Let's increment it by a lesser value. Darker image. Okay. We are close. I don't understand the lines and they're bothering me like hell. What do I do? What do I do? Oh, those lines could be. No, I feel like this is the problem here. This has to be it, right? What if we maybe y needs to be z? Yeah, this is the inverse of what we're doing to get the image, so that should be fine. What if instead of this we do just do double for loops, right? Just 600 pixels, 600 pixels, so we don't have to do any index calculations here, and that shouldn't actually change anything, so not sure about that. But let's bring it back to 20 and commit this. Oh, that looked better. Okay, so somehow 20 iterations is better than 100 iterations. Let's commit this, or no, should we? No, let's not commit this. Let's do it the other way. Okay, so let's change this to size and use that for iterations. So I mean, we're basically doing the same thing. I don't see a problem here. So let's do this size plus equals plus 1, because we are not using the image data anymore. We do that all over again. Or this is row and that is column. Let's do it that way. A row and this is column. And we don't need to do this anymore because we already have row and column. Yeah. Feel like we've done something here. I'm gonna format it, so just let Prettier handle it, but I just want to see if everything else is fine and dandy. Yes, it is. I think so. I don't know. Let's run this and see. What does this give us? it gives us the same bloody thing. So that's not it. So there's no point in doing that, right? I guess that does reduce a bit of complexity. So let's keep it that way. We don't need get image data to handle that for us. Okay, that seems fine. Oh, just 1 second. All right, back again, back again. Okay. We still have that issue. Lines in our code. Lines in our code. Where do those lines come from? Actually, you know what? I'm making a choice right now. We're gonna ignore it. We're gonna ignore it until it actually becomes a problem that we can't ignore anymore. Does that sound good? I think it does. All right. What do we color it based on? We do the iterations, the number of items in the Z list. I mean, I'm assuming it's all going to be, yeah, it's all going to be max iterations, right? 20 steps that we take. That's not helpful, actually. Are any of them infinity? I don't think so. Yeah, doesn't matter. What do we do here? How do we color this? Like in kindergarten, when teacher asked you to submit your start coloring, how do you start? Uh, let's let's change this shade of gray, because right now we are only dealing with the alpha channel. We're just changing the alpha, and yeah, that's about it. But we need to do some fancy coloring shit. I feel like the I feel like maybe the lowest density ones can be colored a certain way, like brighter. No, maybe that defeats the purpose of this, right? What do we do? What do we do? Reference. Time for reference. Where is our reference? how does this guy color it? Because this is kind of pretty, right? When it's noisy, but it's pretty. So something like that. I want something like that. Iterations. Oh, iterations. We can't use that, right? Because for us it's going to be a fixed set of iterations all the time. Because for the mandelbrot set, we are only dealing with the ones that escape, which means it will never break. It will always be max iterations. The length of Z list will always be max iterations. So, that 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 ruins our plan for world domination. Yeah. Shit. What do we do? Iterate I greater than equal to iterations by 50. Oh. I greater than equal to iterations by 10. Oh. Oh, okay. Okay. That's something we can do. Right? So basically, if we are on, if row and column are nah, that would also suck actually. Let's do it anyway. Let's have some colors here. Red RRR equals if row and we need the index here, right? If we have the max number of iterations. Oh no, this is the number of points. Okay. Actually, that does make sense. What if I do, how do we do this? I comma Z? I don't know. Isn't there a way to do this? Oh, dot entries, right? Yep, dot entries. We can destructure it to Z, I comma Z. Okay. Oh shit, where am I? I comma Z, and we can use I to set the color. So if I is greater than equal to Z list or max iterations, isn't it safe to just use max iterations here? I is greater than equal to max iterations. Oh, this would color it by range. So let's do something like let's split max iterations. Yeah, I think this is the way they did it is the right way to do it. Wow, who would have thought? Let's see. Let's just do R comma G comma B is, let's do R as 200 and 0 the way it was. Let's remove that. Hooker. Else I is greater than equal to max iterations by 20. By 10 is too much actually. Oh, maybe it's not. Let's see what happens. Let's do 10, 200, 10, and let's leave it at else. Or let's do 20 as well. And the rest we just leave it. Else we do 0, 0, 0. That's good enough, right? Let's do R, G, oh shit, B. Okay, the formatter screwed it up. That's kind of neat, isn't it? It's weird, but it's kind of neat. Oh wait, actually I screwed it up here. We need 10, comma this, comma that. Okay, what does this give us? More blue. Alright, All right, it's something. Let's zoom in a bit. No, and this is ugly as shit. Let's think it again. Think about this again. Let's do. I don't see any red here, so I think let's make it mostly red. 10 and let's make this green. 10, 10, 10, and then here is the bet of 200. This guy becomes 10, 10, and 10. Okay, a lot of green. Way too much. No, that's not what I wanted. Let's reverse these two. Oh wait, iterations by 5. I greater than equal to iterations. I mean, equal to doesn't make sense. But yeah, I greater than iterations by 5. Yeah, yeah, that does make sense to some extent. Let's reduce this then. Let's do 5, this and that. What does this give us? Let's make this guy blue. Okay, a lot of blue. I guess we just have to fine tune this now. Just 1 second. Oh wait, let me just do this and then I need to see if my dog is fine. Yes, more red. Just 1 second. I'll be right back.